Yes.
All right. Hello, everybody. So today we'll be talking about the second part of week 2, and that's the NavAgents with a state machine. So we've been building up. We've seen how to work with NavAgents, seen how some simple state machines work, and then even gone into some more theory on making state machines a bit more advanced to do some extra stuff that for during the transitions when it enters a state, when it exits a state. So for this assignment, it's NavAgent with a state machine. It is an exploratory assignment where we're providing you a state machine that's already written, so you don't have to build one from scratch for this one. But we will be using this, and we're going to be seeing how we can extend some more functionality, adding a new state. The experiment walks through how to add a pause state to the actual state machine that's all set up for you. Today we'll be taking a look for the lecture at how we could add a separate state just to show you a little bit of a different behavior and things like that. So you will still need to follow along with the material here to get that pause state all set up, but we're going to be doing kind of our own little experiment for today's lecture. So here's the package that you'll download that has the state machine in it. You can click the little download button. And we've got it downloaded. I'm going to extract that. And we have a Unity package. So Unity package, we're going to be importing into an empty project. So I'm going to just use a brand new empty one so it doesn't have any other experiments in it, so we can just look at what this package contains and start fresh. So I've got just an empty project here. We're going to drop that in, import it. And there's 4 folders here with numbers on them and an FSGD end section that actually has the state machine all set up, as well as some example stuff. What we're going to do is change a few things up about how this package comes in, because as it is right now, each one of the named folders has a scene in it, but each scene is named the same thing, just NavMesh. That's not very helpful, because if I'm in scene 4 versus if I'm in scene 1 and I open that up, they'll look the exact same. So having the same name for each scene is not a good idea. We're going to rename the scenes inside each one of these folders to represent like navmesh_1 for the 1 folder, so that we don't get confused about which one we're in and which scripts it's loading. So I just rename that there. And we'll rename number 2_2. Pretty straightforward naming scheme. NavMesh to NavMesh3. Oh no, connection unstable, but come on. And we'll just keep going with NavMesh4. So that anytime we load the scene, at least we'll be able to see which scene we're in. We're currently in the first one. And let's explore what kind of what each one of these scenes gives us. So if I press play on this first one, you see it's got a NavAgent navigating around to the different nav points. Seems pretty straightforward, just about the same as the experiment from last week that you had to write from scratch. If we look at our NavAgent and what script it's running, it's just got a NavAgent script, and let's open that up and see what's in there. And Visual Studio loading. All right. So this should be set up very similarly to what you did last time. One thing that you might have different is that there's this find destination, which gets the specific, or it gets the current nav point and sets the destination to that. So it's wrapped up in this one function. So when we hit a trigger, we'll do the increment, do the bounds check, and it does find destination. So this one's currently not running a state machine here. We're going to stop playing, switch over to our second scene. And so NavAgent underscore better. So our better agent here, we'll take a look at what this does. And it should be just about the same behavior, but we see it's pausing at each one of the nav points. So if we look at the scripts attached to our NavAgent here, you see it does have a NavAgent better script attached, as well as a state machine. So we're going to open both those up. I'll just open the other script from here. So this was our first NavAgent. We're now in scene 2 with the agent better and the agent state machine. First thing we're going to look at is the agent better script. And we see it is just about the same. And there's some comments in here about what changed from the first one. And it is actually saying get the state machine and change to the idle state. So our state machine is actually using that FSGDN state machine to get access to the state machine. There's just one public class in here, or one public function in here to add the states, which we're overriding from the basic machine behavior. We're adding 2 different states to this. There's patrol and idle. It also says which one it'll start off with. So in our patrol state, there's some comments about how this is all working. I'll let you read through those on your own during the exploratory portion. But our idle state has some other functionality in it. We see it's got a float for a timer, and during the execute, which execute is treated like the state's update. It'll run once per frame. There's a few different functions we'll be looking at, and execute's just the first one. It'll run every single frame, as mentioned in here. So every frame this state is active, it'll take that timer, add to it how much time since the last frame, then do a quick check. Is the timer past 2 seconds or equal to 2 seconds? Then reset it for next time and change over to the patrol state. So this is how we're getting our pausing functionality, where it's just idling while it's at one of the nav points. And our next thing, once we change to the patrol state, we're getting that NavAgent component here and telling it to find its destination, which does the set destination and tells it to move based on what its current nav point is. So let's move on to our next scene, an even better version. Let's go ahead and open that scene up. We'll give this a play. I'm going to move my camera around so you can see this a bit better. Yeah. Why my camera controls feel so funky today? All right. We see it's not only moving, but it's also changing color when it hits the different points to give the player some feedback about what state it's currently in. So in most games, you wouldn't have just a change of color. You would have some sort of play animation or something. but this gives us, or at least lets us know that exact spot where we need to do that so that we can have that player feedback. All right, it's in a different state. When it's dark green, it's in the idle state. When it's light green, it's just in the patrol state. Sounds good. Let's explore this script out. And this one, rather than having the separate nav agent and a state machine, we've combined it into just one script. So it simplifies things down a little bit. We're just putting our nav points directly in the script that we're our state machine itself, or our class that we're pretty much considering this entire class as our guard script or agent script, whatever you'd like to refer to it, NPC script. We're treating the state machine class as that. And there are multiple classes defined inside this one script. We see each state is a separate class. So keep that in mind. You're going to have to think about, if I want something to be accessed from our state machine inside one of our other classes, we're going to need to do something for that. So we see the start. Make sure to run the base start so the state machine can run all of its stuff. And we tell it to start moving with that find destination. Still got that add states. This time we're just doing the same patrol idle and then setting patrol as our initial state. Got that find destination so that it's a quick wrapper rather than having to type out get component dot set destination every single time we want to make it just move to its current nav point. On trigger enter, we've seen before, that was on our agent, just doing that increment. And then this one is making sure that we specifically collided with a nav point before we change state. So it's got a little bit of an extra check rather than just changing for anything it gets a trigger on. Control state even better. So we ended that first class here. We're now in our second class that we're adding for the state itself. We're deriving from a basic state, and we're using the enter function here. So enter is called whenever it changes to the state. So when you're calling change state, it'll call enter, similar to how on the script start gets called for the entire script. Now we have an enter for each individual state as well. And we see we're doing the changing color right here. We're actually getting the state machine from inside the state itself. So this is our guard script. Remember that we're casting to that specific type from just a normal machine so that we can get the component for the renderer, material color, and changing the color to green. Our idle state, similar to what we've seen before, but now we've included an enter so that it changes to a dark green. And that's all the same. We're just doing the accessing of the machine here, casting like that. And so this casting can get kind of annoying if you have to type all that out to just access something from our state machine or directly on the agent itself. That's where our best script comes in. So we're in even better now. Let's check out what that best script is doing. Best script, open that scene up, play that, and we see it looks virtually no different. So in game, nothing's changed from even better. But let's take a look at our state machine script. This one is a cleaned up version. There's no longer all those massive comments, since each one is incremental, it explains what changed from the previous one. I do recommend you go through and read how those things are all working. But one thing that we've changed is we're creating a new base class for our NavAgent states. So it gives us a nice, easy function to get access to the state machine within a state. So it just basically wraps up that casting all in this nice one little function, so that in our states, rather than having to do that dirty looking cast, we can just call the function and get access directly to our main agent. And we can call any public functions straight from that inside any of the states themselves. So it's just a cleaned up version in terms of code and usability. One thing to note, rather than our states inheriting directly from a basic state, we now want to make sure that they are inheriting from this child of that state specifically, so we get that. Oh, fantastic. Not sure what happened there. Where did I cut out?
You cut out working on the best script for NavAgent machine.
Okay, so I was on the best script. All right. Yeah. Basically this script cleans up all those comments and everything. So you do probably want to dig through these other things just to make sure you read everything so you understand how that's kind of all working. We've added another helper function here for changing the color.
There's no screen share right now, by the way.
Oh, God, it killed the screen share, didn't it?
Yeah.
Fantastic. All right. Well, let's hope that doesn't happen again. Can you see a screen now? And
I think
everything?
it also killed the recording too.
No, it says it's still recording.
Yeah, the recording came right back. It stopped it and then it came right back.
Yep.
All right. Just making sure.
But appreciate you looking out. Sorry about that. All right. So state machine for the best one. It's all cleaned up. We don't have all those massive comments from before. And all the normies are stealing the internet. Yep, happens right around this time too. I don't know. It's great the rest of the time. But anyways, moving on so we can try and get to the content. So this state machine all cleaned up, none of the comments. Make sure you do go through the other scripts to read through what's changed, how we're making it a little bit more usable, things like that. That we did add this helper function here on the NavAgent state machine itself, so that we can quickly set the color with one simple function call. And then inside the states, before we were just using the basic state, but we're gonna add some extra functionality to that. We're gonna create a new function to get quick access from inside the states to the actual state machine, or the guard itself, the agent itself, whatever you'd like to refer to it as. Each state that is set up is now inheriting from that NavAgent state, so that it has this function. Oh, come on. It's not even storming outside. Jeez. All right. So we now have this function inside the states rather than having to do that dirty looking cast just to get access to the state machine itself. And then we can call any functions straight from that while we're in a state. So it cleans up the code and makes it more usable, quicker to access things from the states themselves. As we can see, it is just basically all that other code cleaned up that we're building up to for in the previous versions. One thing about this, the state machine itself, we haven't taken a look at. Some of this code is written at a very high level. We have the behavior itself. It's inheriting from mono behavior. That's how we can attach the script to a game object. And it also inherits that machine interface. So we're using that interface technique to get some basic functionality out of here. We see it comes with the basic functions, the initialize, update, and what it's doing is going through. One thing you probably haven't seen before too often is the try and catch method, where we're trying to run a function. If there was an exception thrown, then it'll catch that any null references. And if null is an initial state, meaning we never set one, we've added some extra code in here. So if you do get errors while you are using the state machine, be sure to read what those errors are saying. We've tried to add some extra things to say, hey, did you ever set that initial state? Might have forgotten that, or did you change to a valid state or one that's already in the list, things like that. And then it just goes on to continue to wrap all the just normal execute functions inside those try and catches. Animator IK, far beyond this class, we won't be using any of that. You don't have to worry about that. Set initial state, pretty straightforward there. Changing state, pretty straightforward there. There's a couple of options you have where you can use the templated version, or in the parameter specify a specific type. And then going down, there's just about 200 lines of code to get our state all set up. As we can see, it is using a dictionary for how it stores the different states. And then we'll check out the machine interface. Machine interface, pretty straightforward, just defines all those different functions that we want to be able to call between different, for the state machine itself. Machine state, that derives from a basic state, so we should probably look at that first. State inherits from the state interface. State interface, it's just a quick and easy way to make sure these are the functions that every state will have. Initialize, enter, execute, physics execute, post execute, exit on animator IK is active, and getting the machine. So the state itself fills out what those functions do. Since this is our basic state, the functions pretty much do nothing. Other than in initialize, it'll have some debug code to print to the console when it is changing those different states. When it enters a state, it'll let you know what its current, what current state it's in, things like that. And while you may not understand how all of this is working, I do recommend taking a look at it and slowly breaking down the parts that you do understand. So I froze again for about 15 seconds. Can you hear me now, or was the video frozen? Oh, there it goes.
Yeah, everything's good now. It's just, you know, here and there.
All right. Well, I am recording locally, so the video should be good. Was there?
That's absolutely a saving grace for when we go back through this later.
Yeah. Sorry about it. Just happens to be right around this time. It goes a little bit on the fritz. All right.
Spectrum consistently screwing people over.
Well, I'm trying to help you guys not screw you guys over for sure.
Right, yeah, exactly.
Yep. So we're in the state.cs. We took a look at that. Machine state is going to be a state. It also has that machine interface so that it comes in with that add states and all the basic stuff of how the state machine is actually working, where initialize for each state will initialize it, add the states, and for each loop kind of initialize each one of the states that was added. Are you serious again? Okay. The execute just runs a basic execute, and then it's also checking. So execute, remember, is kind of like our update. If we were told to exit a state, it'll exit that state, switch the state to the next one, reset next state to null, and just toggle a couple of bools to keep track whether it needs to call enter. So onEnter gets set to true, onEnter gets called for the current state, which would have just been changed if exit was set. So exits the old state, switches to the new state, then calls enter on it. Then it does an execute to run the update of each state. Since this is running per frame, we need somewhere to have some access to things we need to do per frame. We have the physics execute, no need to worry about that. And post execute, nothing to worry about that. Animator IK, as I mentioned before, nothing to worry on that front until you get further into a physics system or something like that that really needs IK. We see here's the change state, how we can change, what it actually does, make sure that the state you pass in, or that the state, if it's already set to change to another state, lets you know, hey, you're trying to change to a state, but this frame we've already been told to change state. So it just gives you that warning there. So keep an eye out for any of the print strings that might happen. So moving on to actually extending this state machine, we don't have to worry about anything from the FSGDN. We'll just be using those different things inside our state machine itself. State machine itself that's we're using is this NavAgent state machine best. All right. So basically the one I want to show you is we'll add a new state that can follow a player around. I'm going to need a little bit of a setup for this. So our characters just going willy-nilly constantly through this infinite patrol. But let's add a new state where it'll chase after a player. So I'm going to throw in a player. Oh, and we see it's super tiny. Let's bump that up by 3. We'll add a character controller just to get this guy moving around. We'll add a quick script for it. Player. We'll go ahead and open that script up. And we'll get this moving just like we did before, just getting that character moving around the previous level. On start, I will want to capture or get the character controller component. Character controller, CC, equals null, so it won't give me any of those warnings. Start, we'll grab the component from our game object. Get component, character controller, and in update, we will tell it to use that. We'll be using a vector 3 for our movement. We'll be initializing that. to our input, get axis, and we'll be doing vertical first. Multiply that by our current forward. And then we'll add in sideways movement. Input, not impug. What the heck's impug? Get axis. Hopefully I spell horizontal right this time. Yay. Multiply that by our right vector. And tell our character controller to move it. We'll use that simple move, and we'll do our movement. And this is a speed, so I'll multiply it by 5 units per second. Since our movement is just getting which direction we want to move, we'll just scale that up a little bit so it does have a bit of a speed and isn't insanely slow. Should be able to test this out. Press play. And using WASDA, we got our character moving around. It's kind of slow, so I'm probably going to bump it up. It's about the same as the other character. That's fine. So now I want to add a key where we basically, if we press a button, we're going to switch this character's state to a follow state. So we're going to need to add that state to our agent and have it switch based on an input press. So go into the agent script. First thing we're going to want to do is add the new state so we can tell it to change to that state. So our states, I'm going to go outside of all the other classes at the very bottom. So we've already closed our last class and we are outside of any other classes. We see they're grayed out here. And let's go ahead and add a new public class. We'll call it follow state. We want to derive from our NavAgent state. So we have that quick, easy call functionality to get our state machine. When it enters this state, I want it to change the color. So I'm going to basically use this other state as a reference here. I'm going to grab that entire enter function, copy it entirely, and then just make the changes I want. Don't need any timer, but I do want the set main color. Color I'll set to, and we'll just use a color.color. What color would you guys want to see it change to?
Red.
Red?
Red means danger.
Red means danger. It also means stop.
That too.
So we'll go red. And
Or potential danger.
or potential danger. Huh? I'd say yellow would be more of a caution in state, but red, yeah.
Yeah, I was thinking
We'll go
more
with
along
red.
the stop signs. Red means stop because of potential danger.
Red means stop because that's a good one. Okay. So then we need to actually tell our character to switch to this. So I'm going to add an update here. Update, and we'll check for an input press. The problem is we see that when we added update, it's hiding an inherited member because machine behavior also has update. That's how it updates the state machine itself. What we're going to want to do is override this instead, and can't override a private member, so we'll make it public. Override And we will make sure that it calls the base update so that our state machine still runs. Then we can add anything else we want to our update, which updates are a usually great place to do any input checks. So we'll look for input dot get key down. And since this is a chase, the experiment will have you set it up on space for the pause. So I will say if we press F, so in what is it? Keycode.f. If we press F, I want it to change to the chase state. Or what did I call it? Follow state. So we'll change state. We're going to use the templated version. I called it follow state. We'll see what we can do with that. So right now it's not going to follow, but we should at least test it in the stage like, all right, is it at least even changing red? That's our first step. We'll get that changing color and then worry about the following code. So just change state to that, save that. If we play our game and we press F, F is not a good button, but we are not changing the color and we are getting an exception. So we see here one of those prints saying, did you add the state you're trying to change to? If we look at the code and we just double click this, it's going to bring us to where that print was happening, where it's throwing that exception. But if we look down in the more advanced version of this console down below, we have a lot more. We actually see the call stack of how we got to the print or the exception. So we can go all the way up at the very bottom down here. We see that's from our script that we're writing in on line 57. So change state, follow state. Did we add the state we're trying to change to? Well, no, our state machine knows nothing about it. Even though it's in the same script, we have to make sure to add it to the state machine. That happens in the function up here, where we're adding each state, then setting which state it's going to start off in. We also need to add that new state, the follow state. So we'll add follow, save that, give this another run, press F, and we do have it change color to red. Our next step would be to get it to, well, start following when that happens. So since I want it to follow our player, my agent will need to know about our player, and so it can reference it in the game. So what we're going to do is just add a serialized field so we can set it right here in the editor. So our agent script on the state machine, we'll go ahead and add a new serialized field. And this will be our, we'll get a game object reference. And we'll call it player ref. Initialize to null so we don't get a warning about it. So one thing, I just did a Control-Shift-B, which is build, and we do see we are getting warnings from just a couple of things. Our player ref, we're not using it yet. All right. Our start was empty for our nav point. So our nav point, this was something that we came with. They did leave the start and update there. I don't like warnings, so we're going to clean that up. save that. And then we just have to use our player reference. So way down here in the follow state, other than just setting the color, let's tell our NavAgent state machine to get access to the actual agent itself. We'll get our NavMesh movement component, or NavMesh agent component, because that's where our set destination is. Set destination. We'll tell it to move to our character's position. So we have our player ref. Player ref. What did I call it up top? Oh, that's right. So this state doesn't have that variable. So player ref only exists inside the state machine. I could make it public and then have this and then get the player ref from that, but as we can see, this line of code's already doing quite a bit just in one. So instead, what we're going to do, similar to how our idle state or patrol state does the find destination call, we're going to add a helper function inside our state machine best that we can just call from the state to tell it to move to our player. Public void, we'll say move to player. Very appropriate name for what this function will do. We'll get our NavMesh agent component. NavMesh agent. Set destination. Bars are getting in the way. And for this, we'll use that player ref. We'll get its transform dot position. So telling it straight forward, move to our player's position. Then down here, rather than having to do the get component, set destination, all that stuff here, we can just call that move to player function. Keep in mind, I did have to make move to player. If we look at that again, I made it public so the state could actually access this. If I left that off, the state wouldn't be able to access it because it's another class. But now that we have that all set up, should be telling to move to player. So we press play, and I'm gonna move my character, let's say down here, and I'll wait till it's coming by. If I press F, we see it didn't move to our player. If I press F, we see it's ignoring the move to player. I have an unsigned reference. I was not paying attention to the output log. It's spitting in my face. I forgot to tell it about the player. So getting the player's position was a no-go. So we'll tell it about our player. And, oh, I didn't name my player, so it's just capsule. Fantastic. Let's fix that. Player. There we go. And now that we have our agent know about our player, try this one more time. Get my character over here, wait till it's right about there, press F, and we see it's navigating to our player. Now, as I move my player around, it's not quite following our player. It's just going to that position where I first hit F. That's not very good. I could press F here and it will call it over there, but doesn't follow. So I want it to update to the player's position. So every frame that it's going to be inside this follow state, we can use our execute. So I'll do an override on the execute because that's our update when we're working in states. We'll also tell it to move to player. So it's going to set that destination every frame. So if our player moves, it'll keep moving towards our player. Save that. And run over here, wait for it to get out of that. Press F. And we see it's going to chase our player. Now we do have an odd behavior where I just dragged it into one of the patrol points and swapped to idle, and it's just back to its normal patrol. Well, if I have it chasing a player, I need to take into account what happens when I hit one of these patrol points. I want to make sure that I should care about a patrol point when I do hit it. So our patrol points are handled with the on trigger enter when we hit one of the nav points. And right now we don't care which nav point we hit. So that's going to suffer from the same issue that we had last time, where we want to make sure that not only is it a nav point, but also is the nav point that we're looking for. So making sure that that is equal to my nav points sub nav index. So that's one issue fixed, but we still have the problem if we're chasing the player, we really shouldn't be caring about nav points. So I'm going to add another check here. So we're going to beef up the if conditions. And we're going to add making sure that we should only care about this if our current state, so is current state is how we can check, is this the current state? Our patrol state best. So that when we do hit it, unless we're in our patrol state, then we don't care about anything, any of the nav points that we hit. So now it should chase me even if I make it run over the nav points. All right. Go ahead and give that a play. And I'm gonna, right now it's even at a nav point, I'm gonna press F, should chase. And we see it's chasing through the nav points, continuously chases. And there's no way to make it stop chasing. Let's make it so that when we press F, that it toggles whether to go into that state or out of that state. So in our update, we have it pretty straightforward. If we press F, we're changing state to follow state. Well, let's add an if here. When we press F, I want to know, are we already in our following state? I can check is current state, following state. If it is, we'll want to change to some other state. I could change back just to the patrol, so it goes back to its current current nav point. In fact, let's do that. Let's do patrol state best. We need a change state, of course. change state to the patrol state best. All right, give that a save. Let's play test this. Press F, should start chasing me as I run through him and push him back. If I press F again, should just go back to patrol and start moving around. All right, we now have a way to toggle states. We do have a bit of an issue right here. I see it is already changing states. I don't know if I pressed F twice or I might have screwed something up with our, I did screw something up. I know I did because we just got a second one. So I forgot to put this in an else. So since it was one line, I wasn't going to use a body on that. So forgot the else there. All right. So what was happening is the state machine was preventing me from doing the change twice. So when I told it this one at the bottom, it ran this, it was in the follow, oh, come on, I didn't mean to click that. It was in the follow state, so it did the change state, and then it was also running change state, follow state, which was producing that error. You can't change twice when you're already, when you're within one frame. So made sure to let me know, all right, well, I didn't mean to run two change states there. Should only be running one or the other. All right. So now when we play, press F, 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 no errors. And it can't make up its mind whether it wants to go to that point or follow me. All right. Any questions about how to add a state, how the change state is working, how to check what current state you're in? No questions?
Nope, I'm good to be honest. You do a pretty good job explaining stuff.
Fantastic to hear. Thank you. So I will leave you to it then. Make sure you do go through the assignment itself that basically walks through how to add a state. You'll be adding pause. It explains how that pause functionality should work. And make sure when you are taking the screenshot, it does have all of the requirements. There's 10 requirements on this one, so make sure that you check each one. Alrighty then, that pretty much wraps it up for today. It was kind of a shorter one today, but hope you enjoyed the session, and feel free to reach out with any questions that you have on Discord after. Thank you again.
Good.